Welcome to Module 3. This module focuses on evaluating coverage of deaths of women in reproductive age. It has 3 episodes: an introductory episode describing the Brass Growth Balance Method, a second episode describing the General Growth Balance Method, also called GGB, and a third episode describing the Synthetic Extinct Generations Method, also called SEG, as well as the combined GGB and SEG method. In addition to the 3 episodes, there are 3 additional sets of materials available for you. Annex 0 presents methods for evaluating population, age, and sex distributions. Annex 1 contains detailed information on the GGB method, and Annex 2 covers the SEG method. Let's start with Introductory Episode 1. The goal of this first episode is to introduce you to the logic behind methods for evaluating coverage of death recordings of women of reproductive age from censuses. We will cover the Brass Growth Balance Method, one of the first methods for evaluating the completeness of death recordings from census data. Although this method is not incorporated in the Census PRM workbook for estimating maternal mortality from census data that is covered in Module 5, this description of the Brass Growth Balance Method will allow you to understand the general logic behind the Generalized Growth Balance Method, or GGB, and the Synthetic Extinct Generations, or SEG methods. Here is a description of the contents of this episode. Remember, their accuracy of estimates on maternal and pregnancy-related mortality depend on the quality of the data we use. In the first part, we present the concepts of census data completeness and reasonableness. Remind ourselves of the components of the main measure of maternal mortality already covered in Module 1, and also the importance of evaluation of death and birth recordings from census data. We will then move to describe the Brass Growth Balance Method, its assumptions, logic, and caveats. At the end of the episode, please make sure you take the time to answer and review our learning assessment. For the purpose of this course, data completeness refers to the degree to which the members of a population and household deaths and births are reported in a census. Data reasonableness refers to how close is the age and sex distribution of observed counts to the expected distribution of people, deaths, and births reported in a census. Evaluation is always needed. We cannot assume that census data is 100% complete previous an evaluation, or that all data are reported accurately. After evaluating and adjusting the data, we can produce measures of maternal mortality that reflect the risk of maternal deaths per woman, the risk of maternal death per birth, the overall levels of fertility and mortality. Remember that for distinguishing between other causes of death, pregnancy-related deaths, and maternal deaths, we will need to know if the deaths were accidental or non-accidental, and if they occur within the 6 weeks after the termination of pregnancy or delivery. Not counting all deaths, births, or population in a census might lead to biased estimates of pregnancy-related or maternal mortality. Counting fewer household deaths results from sensitivity of household members to talk about recent deaths in the household, and particularly of maternal deaths resulting in refusals, or household decomposition following the death of a household member, or recall bias. Let's define recall bias. It is the respondent's ability to remember details accurately or omit certain details. For example, the respondent incorrectly includes someone who died 2 years ago in household deaths. Census questions about mortality in the household should only include deaths of household members in the last 12 months. These biases might lead to underreporting of adult female deaths. Because of these biases and the complexity of census operations, Before estimating any measure of maternal or pregnancy-related mortality, we need to evaluate census coverage of population, death, and birth records. Modules 3 and 4 contain information on the methods incorporated in the census PRM workbook to evaluate and adjust population, deaths, and birth counts from censuses. Let's look at all the components that we need to evaluate in order to generate quality measures of pregnancy-related or maternal mortality. Remember, in Module 1, we introduced these measures. The pregnancy-related mortality ratio, or PRMR, is a central measure of obstetric risk. It is the number of pregnancy-related deaths per 100,000 live births in a population. To estimate the pregnancy-related mortality ratio, we need data on deaths of women of reproductive age, usually women between ages 14 to 49. We also need the proportion of those deaths that are pregnancy-related or within 6 weeks of termination of pregnancy or delivery, and the number of births within the period of observation, usually 12 months before the census date. Therefore, we need to evaluate the completeness of deaths and births in census data. To do this, we assume that the proportion of pregnancy-related deaths of all deaths of women of reproductive age has the same coverage error than the deaths of all women. The methods for evaluating that we present in this module focus on the evaluation of death records in general. Evaluation of births is covered in Module 4. Before you evaluate recorded numbers of deaths of women from the census data, it is always good practice to check the smoothness of the distribution of age and sex of the population you are analyzing. If you check the sex and age distribution of your population for age heaping and consistency of sex ratios, you will have more information about the quality of your data, and you will be ready to focus on evaluating records of women of reproductive age. If you want to know more about these methods, please review Annex 0 in this module. Although we are interested in evaluating death records of women in reproductive age, the methods are developed to evaluate deaths at all ages post-childhood. It is important that deaths of older women are recorded and included in the analysis. If you want to double-check your results, it is recommended that you also evaluate male deaths and check for reasonables of coverage of census death records for both sexes. All these methods compare the distribution of death rates estimated from census data with death rates implied by the population distribution. There are 4 methods that compare the distribution of death rates estimated from census data with death rates implied by the population distribution. These methods are the Brass Growth Balance method and its generalization, the General Growth Balance method, or GGB, the Synthetic Extinct Generations method, or SEG, and the Combined GGB-SEG method, which is the preferred method for evaluating death recording of women in reproductive age. In this episode, we start with the Brass Growth Balance method, and in the next episodes, we will cover the other 3 methods. The logic behind the methods described here is that death rates estimated from census reports are compared to death rates implied by the population age distributions. If deaths implied by the population age distribution are higher than the observed death rates from census data, then there are less deaths reported in census data than expected. The general idea behind the evaluation method is to compare age patterns of 2 similar measures. One true pattern estimated from demographic identities, like the population balancing equation, and one observed pattern estimated from census data. The method assumes a discrepancy between the true pattern and the observed pattern, and based on this discrepancy, we can calculate an adjustment factor. This adjustment factor is applied to the observed data to obtain measures closer to the demographic reality of a population. It is important that you consider the assumptions behind the Brass growth balance method as they apply to the data for the country you are analyzing. There are four assumptions. First, the population is demographically stable. This means that the population has been subject to the same fertility and mortality conditions for a very long time, and its growth rate is constant across all age groups. Second, completeness of reporting of deaths and population does not vary by age. This assumption might be incorrect in the presence of substantial age misreporting or high urban to rural migration in older ages. Third, errors of age reporting are not systematic and large. And finally, the fourth assumption is that population is close to migration. If the census being analyzed is the only one in the last 15 years or so, or the only one ever, apply the Brass growth balance method. This method assumes that the underlying population is demographically stable. That is, birth and death rates have been constant for a long period of time, and the population age distribution has acquired a characteristic shape reflecting those birth and death rates. It is important to understand that a demographically stable population does not necessarily have a fixed size. It might be growing or shrinking, but the growth rates are constant across all age groups, such that the overall proportionate age structure does not change over time. Today, stable populations are rare or non-existent, but if no additional data are available about age-specific growth rates, there is no satisfactory alternative to assuming stability. The number of deaths recorded from a census can be evaluated for completeness using the Brass growth balance equation under the assumption of a stable population if the other three assumptions are also met. The demographic balancing equation states that in any population, population change over a defined time period is equal to the balance between entries in the population and exits from it. The same is true of rates of change. So the growth rate R is equal to the difference between the entry rate and the exit rate. If there is no migration, entries will be births and exits will be deaths, so that the birth rate B is equal to the death rate D plus the growth rate R. This necessary balance in the demographic balancing equation applies not only to the whole population, but also to open-ended age segments of the population, that is, the population age X and above. Then, we can say that in an stable population, the entry rate or birthday rate into each open-ended age segment is equal to the true death rate for that segment plus the constant growth rate. Bx plus the entry rate into the population segment age X and above is equal to Rx plus, or the constant growth rate of the population segment age X and above, plus the X plus true, the true or implied exit rate from the population segment age X and above. Remember that the method compares age patterns of two similar measures. One true pattern estimated from the population balancing equation, as shown in the previous slide, and one observed pattern estimated from census data. The X plus observed is the observed death rate in the population segment age X and above. There is an important difference between the true and the observed death rates. The true death rate is the one we will observe if all deaths in the last 12 months previous to the census were recorded. However, we know that we expect less deaths in census reporting than they should have been reported due to the biases we mentioned earlier. We compare a true death rate estimated from the population balancing equation to its equivalent, which is the observed death rate multiplied by an adjustment factor. Let's talk about the estimation of the adjustment factor. The first equation, birthday or entry rate above hx, is equal to constant growth rate above hx plus true death rate above hx, implies a linear relationship between the entry rates and the two death rates. Remember that the two death rate estimated from the population balancing equation is equivalent to the observed death rate multiplied by an adjustment factor, as shown in the second equation. The second equation also indicates a straight line between the entry rates and the observed death rates with intercept r and a slope 1 over c. Fitting a straight line to the plot of the entry rates against the observed death rates for all possible age segments provide estimates of both r and 1 over c. Note that the Brass growth balance method, in common with other methods presented in this module, assumes that the completeness of death recording is constant at all ages. If deaths are incompletely reported, the true death rate will be equal to the observed death rate multiplied by an unknown factor, which is the inverse of the completeness of death recording, C. The logic behind the method is that the entry rates, based on the population distribution by age, should correspond with the distribution of deaths. By fitting a line, the researcher then finds any problematic death reporting and estimates the adjustment factor, C. So now that you know about the logic behind the Brass growth balance method, let's review its main assumption, that the population is demographically stable. What if in the country you are analyzing, mortality and fertility rates have changed in the last 10 to 20 years? Well, the assumption of a stable population is often violated. Mortality and fertility rates are changing in most countries. To release this assumption, in the next episodes of this module, we cover methods that do not assume a stable population model. The Generalized Growth Balance Method, or GGB, the Synthetic Extinct Generation Methods, or SEG, and the Combined GGB-SEG method. Let's assume that you have data from 2 consecutive censuses. Then, instead of using the Brass Growth Balance Method, you will use the Generalized Growth Balance Method, which incorporates observed age-specific growth rates in the intercensal period. The second method, the Synthetic Extinct Generations method, also uses data from 2 consecutive censuses to generate age-specific growth rates and compare the observed distribution of deaths to the expected deaths in a stationary population. A stationary population is a stable population with 0 growth. Please select the correct answer for the following 2 questions. Question 1. If you have data from 1 census, you should use A. Brass growth balance method, B. Generalized growth balance method, or C. None of the above. Question 2. True or false? To estimate quality measures of maternal mortality, you only need to evaluate death recordings from a census. Here are the answers for the questions. First question. If you have data from 1 census, you should use the Brass growth balance method. The GGB or SEG methods require data from 2 consecutive censuses. Second question. The statement. To estimate high-quality measures of maternal mortality, you only need to evaluate death recordings from a census is false. You also need to evaluate census coverage of population and birth records.